Good morning, students. In the last class, we discussed about started with a new chapter that is atoms. So, atom is a basic unit of the matter, right? So, in this chapter, we have concentrated on the three atomic models. That is, first the atomic model was proposed by the J.J. Thomson. So, hence the atom model name is given by Thomson atom model, and the next is Rutherford atom model, and the third one is Bose atom model. So, in the last class, we discussed about the Thomson atom model and Rutherford atom model. So in Thomson atom model, the positive charges are distributed over the volume of the atom, and the negative charges, that is electrons, are embedded in it like the seeds in a watermelon. So hence the Thomson atom model is also named as, that is, plum pudding model. So later that the Rutherford atom model. So in this atom model, the entire positive charges and most of the mass of the atom are concentrated into a small volume. So that volume we call as the nucleus, and the electron, that is negatively charged particle, is revolving around the nucleus. That is like the planets which are revolving around the sun. So hence the Rutherford atom model is named as the planetary atom model. So first the concept of the nucleus is proposed in this theory, that is Rutherford atom model. Hence the Rutherford atom model is also named as the nuclear atom model, right? For that the entire mass, that is positive charges and entire mass of the atom, is concentrated into a small volume. So that we call as the nucleus, and the electrons are revolving around the nucleus. So this one the experimentally conducted by the Rutherford. So that experiment name is given as Rutherford alpha scattering experiment. So Rutherford conducted the experiment to observe the nucleus and also the electrons which are revolving around the nucleus, right? So he conducted the experiment, that is alpha scattering experiment. So what are alpha scattering? So alpha are the particles which are having the mass of the helium nucleus. So what are alpha particles means? So alpha particles are the nuclei of the helium atom, right? So alpha particles are the mass of the helium nuclei and its charge. So the alpha particle charge is equals to plus 2e, right? So here the alpha particle is positively charged, that is positive charged particle. So alpha particles are the positive charged particle. So what are alpha particles? Alpha particles are the mass of the helium nucleus, right? Or we call as nucleus of the helium atom, right? So what are alpha particles means? Alpha particles are the nuclei of helium atom, right? So what are alpha particles? Alpha particles are the nuclei of the helium atom, and its charge is plus 2e. So by using this alpha particle, so Rutherford conducted the experiment, that is Rutherford alpha scattering experiment, right? Now we will discuss the experiment, that is Rutherford alpha scattering experiment, or it is called as alpha scattering experiment. So the experimental setup is, so box containing the alpha particle. This is source of alpha particle. So here the source which are using the alpha particle is bismuth 214 and 83. So this one is the alpha particle, that is source. So this source is kept in the box, right? So this is the experimental setup. So here this one is the source of the alpha particle and this one is the thin gold foil. So this blue color strip is this one is the thin gold foil and this one is the zinc sulfate ZNS. So zinc sulfate plate. So this horizontal is there. So this one is the zinc sulfate plate and this one is the microscope. So this hole we call as the detector. So this detector consisting of the zinc sulfate plate along with the microscope. And so this one is the experimental setup. So in the experimental setup, first we consider one the alpha particle source. So the source is the bismuth, right? So this one is the radioactive source. So this source will emit the alpha particles. So alpha particles are made to fulminated beam. That is the beams which are made parallel. So the alpha particles which are emitting from this source are made to parallel by this, that is by this wall, right? So here the electron beam, the alpha particle beams which are emitted from this source are made by the, that is made to the parallel, and these beams are made to incident on the gold foil. So thin gold foil of 0.21 micrometer. So the thickness of the gold foil is about 0.21 into 10 to the power of minus 6 meter. So that one is the thickness of this gold foil, that is thin gold sheet, right? So the alpha particles which are emitted from the source is made to incident on the gold foil. So this gold foil has the thickness of the, that is 0.21 micrometer, right? So here the scattering of the alpha particles takes place. So scattering will takes place in all the directions, right? So this one is the detector circular table. So on this circular table, the detector is there to observe the scattering of the alpha particles. So this detector consists of the zinc sulfate plate and also the microscope, right? So these are the alpha particles, scattered alpha particles. So these are the scattered alpha particles. That is, when the alpha particles which falls onto the gold foil, then the alpha particles will scatter in all the directions, right? So these are the scattering of the alpha particles. That is, the red color which are representing the arrow marks. That is beam of the alpha particles. So these alpha particles are detected by using the detector on a circular, which is placed on a circular table. So it consists of a zinc sulfate plate and along with this microscope. When these beams which falls onto the zinc sulfate plate, so the light flashes will be observed through this microscope, right? So by this the scattering of the alpha particles are observed. That is, when the beams which falls, that is alpha particle beams which falls onto this zinc sulfate plate, the light flashes will be observed through this microscope, right? And that for that reason only we are placing the zinc sulfate plate, right? So when the beams which falls onto this zinc sulfate plate, the light flashes will observe. So that one will see through the microscope. So this entire setup is called as the detector, right? So here if you observe, the scattering will take place in all the directions. So here this scattering we call as low angle scattering, right? So almost these are parallel to the incident alpha particles. When it falls onto the zinc sulfate plate, the scattered particles has very less angle. Hence, these scattering particles or scattering beams are called as low angle scattering. So here these are the high angle scattering, right? So this one is the high or large. These beams are the large angle scattering, right? So the scattered particles, that is alpha particles, which make certain angle along with the axis. So that scattering particles are called the large angle scattering. And one more, here we are getting the backward scattering. So this is the gold foil, and when incident on it, it gets reflect. Hence, these scattering are called the backward scattering. Right, so here we are getting three scattering particles. So one is low angle scattering, and another one is the large angle scattering, and third one is the backward scattering. When the source, that is radioactive source, which emits the alpha particles, so radioactive source which emits the alpha particles which are made to collimated beam, that is alpha particle beams made to incident on this gold foil. It has the thickness of 0.21 micrometer or 0.21 micron, right? So some particles, that is alpha particles, will scatter around all the direction. So here from this experiment, by using the detector, we are getting the low angle scattering and large angle scattering. That is, the scattered particles make certain angle with the axis. So that one is the large angle scattering, and some particles, alpha particles, is reflect back. So those are called the backward scattering. Right now, by this experiment, he plotted the graph. That is, plotted the graph number of particles, that is n of theta, that is number of alpha particles which scattered, right? So here we are getting the number of alpha particles which are scattering to that of the angle, right? So here we are getting the theta, right? So here angle of scattering. So from this experiment, he plotted the graph, that is number of alpha particles, right? So the number of alpha particles scattered versus the angle of scattering, right? From this observation, so from this experimental observation, he did the plot like this, right? So here it starts with 0, then here it is 1 degree, 2 degree, right, and so on. So up to 180 or 360 degree, right? So here the number of alpha particles which are emitting, that is which are scattering, right, to that of the angle. So that one can be observed through the detector. When the alpha particles which are scattered that falls onto the zinc plate, then here we are getting the light flashes. Then only we can say that the alpha particles are scattered. So that light flashes, that is the light which are observed through the microscope, right? So from that observation, so this detector can be rotated on this circular table, right? So here from 0 degree to 360 degree, if we make the readings, then he get the plot like this, right? So from this experiment, so this one is the experiment. So from this experiment, he noticed a few observations. So observations which are made by the Rutherford after conducting this experiment, right? So the alpha particles, simple experiment, the alpha particles are made to incident on the gold foil. So after incident on the gold foil, the alpha particles are scattering in all the directions. So that scattering is observed through the zinc sulfide plate with connected with the microscope, because the light flashes will incident on the zinc sulfate plate can observe through the microscope, right? So after that he plot the graph for number of alpha particles which are scattered to the angle of scattering, so that is theta, right? So if this detector is placed here, means the angle theta is 0 degree, right? So after here it may be 10 degree, 20, like this, right? So this one is the graph. So from this graph observed three observations. So the first observation is most of the alpha particles, most of the alpha particles pass straight through gold foil without scattering. So this one is the first observation. So from the first observation, the alpha particles which are coming from the source. So here the source using is the bismuth, and here the thin sheet which are using is the gold foil, right? So when the alpha particles which are made to incident on this gold foil, so the maximum number of the alpha particles which are not scattered, so which will pass straight through it, right? So if you observe here, so hence here we are calling this one as the low scattering angle, right? For 0 degree we are getting the maximum. So if you observe here, so here we have 1 degree means we have the maximum number of the alpha particles which are scattered. That is, as it passes straight, hence we call that the alpha particles which are not scattering, hence they are passing straight, right? So if you observe the graph, means for lesser angle we are getting the maximum number of the scattered alpha particles. So as the angle increases, this detector angle increases, then the number of alpha particles which are scattering goes on decreasing. So if you observe here, so this one is the graph. From this graph he concluded that the most of the alpha particles pass straight, right? Pass straight through the gold foil. So this one is the gold foil, pass through this gold foil without scattering. So from here 0 to 1 degree, this is almost very lesser angle. So here we are getting the maximum number of the alpha particles which are passing through this gold foil, right? So hence that one we call as a low angle scattering. So this one is the first observation, right? So second observation is only 0.14% of the alpha particles scatter at an angle more than 1 degree. Right? So over 100% alpha particles which are coming from here only 0.14%, right? So only this much percent will scatter here more than 1 degree, right? So after 1 degree, so this one is the 1 degree, after 1 degree only 0.14. So if here the alpha particles emitted are 500, so out of 500 only 0.14% will scatter more than 1 degree, right? So this one is the second observation. So and the third one is about 1 in 8,000, that is about 1 in 8,000 deflect by more than 90 degree, right? So this one is the third observation. So here the first observation is about the low scattering, that is low angle scattering, and the second observation is large angle scattering, that is 0.14% of the scattered alpha particles will scatter, that is on above 1 degree. So this one, the second point is about the large angle scattering, and the third one is about the back scattering. So if here the 8,000 number of alpha particles are emitted from this source, means out of 8,000 only one alpha particle will reflect back. When it falls onto the gold foil, then it will reflect back only one out of 8,000. So that means the angle theta is more than 90 degree, right? So if you observe here, so this angle is 90. So after this, that is greater than 90 degree. Only one particle out of 8,000 deflect more than 90 degree. So we say that one as the backward scattering, right? So this one is the third observation. So the first observation is most of the alpha particles will scatter, that is at the low angle, that is it will go straight without scattering, that is nothing but for theta is equals to 0 degree we are getting the maximum scattered particles, that is alpha particles. Hence for that reason only we are getting the n of theta is nothing but, so here n of theta is the number of scattered alpha particles. So for that reason only we are getting the maximum alpha particles without any scattering. So that one is the first observation. So second observation is out of total number of alpha particles which are emitted, only 0.14% of the scattered alpha particles is greater than 1 degree. That is theta is more than 1 degree, then the alpha particles emitted is very less number, that is 0.14% of total number of the scatter, that is the alpha particles which are produced by this radioactive source. And the third one is out of 8,000 alpha particles, only one alpha particle will reflect or will pass through greater than 90 degree. So right, so this blue line is along horizontal, this gold foil is vertical. So that means this angle is 90 degree. So above 90 degree, only one alpha particle will deflect by more than 90 degree.
Now, so first he observed these three observations, then he gives the explanation for these three observations, right? So first start with about 1 in 8,000 alpha particles deflected by more than 90 degrees. So what's the reason for the backward scattering, right? So he gives the explanation for this one, right? So the explanation for this is to deflect the alpha particles. So as already says that, so alpha particle is nothing but the positive charged particle, right? So that means this one is positively charged. So this gold foil is nothing but this one is the element which is made up of the atoms, right? So here positive charge which falls onto this gold foil, then it gets scattered backward. So hence this one is the backward scattering. So the reason is that to reflect back, that is here the alpha particle is positively charged, then as it approaches near to the gold foil, then it reflects back nothing but here we have the positive charge. For the reflection, for repulsive, there must be a larger force. So that force is produced by the atoms which are present in this gold foil, right? So first he says that, as already said, the alpha particle is positively charged. When positively charged particle approaches near to the gold foil, then it reflects back. That is nothing but it is the repulsive force. So what is the reason for the repulsive force? Is nothing but the atoms which are present in this gold foil will give the repulsive force. That means these atoms will consist also the positive charge, right? So here also the positive charges and here also positive. So like charges, what happens? So like charges will repulse. For that reason only the backward scattering will takes place, right? So he gives the theory that for this explanation, why out of one, that is out of 8,000 only one particle is deflect more than 90 degrees, that is backward scattering means here the alpha particle is positive charge, right? So as already says that Rutherford hypothesis says that the entire positive charge is concentrated into a small volume, right? So this one is also the positive charge. From the Rutherford hypothesis, he says that already he says that the entire positive charge and mass of the atom is concentrated to a small volume. So that one we call as the nucleus. As the alpha particle is positive charge, when this positive charge will approach near to this gold foil. So this one is the atom. So atom consists of the positive nucleus and the electron is revolving around the nucleus. That is, this gold foil consists of number of atoms, right? So as this alpha particle will approach near to the atom, so due to this positive charge and here also positive charge, so there will be the repulsion takes place. So hence here the backward scattering takes place, right? So for repulsion there must be a larger force for repulsion. So hence the theory says that the entire mass and the large positive charges are accumulated in a small volume. So this gives the repulsive force for this alpha particle. So from this he concluded the theory of the nucleus. So the existence of the nucleus in the atom, right? That is, when the alpha particles approaches near to the atom, so the repulsion takes place. The repulsion is because of the strong positive charges which are present in the nucleus, right? So for that reason, from this observation, so the existence of the nucleus, that is, he explains the existence of the nucleus, right? So here positive and here positive, hence here reflect, that is repulsive back, it will not attract. So if it is negative means it will attract, right? So here the electron is also revolving around this nucleus, but this electron is very less number of the charge, hence it will act more force from this positive charge, hence it will reflect, right? So that is the argument, that is the hypothesis of the nucleus in the atom, right? Experiment he also says that the existence of the nucleus, that is how means the alpha particles will reflect, that is repulsive force which acts by positively charged nucleus, right? So this is from the first observation, right? So next he gives the explanation for this one, that is first observation. Most of the alpha particles pass straight through the gold foil without scattering. So he gives the explanation for this as the alpha particles. So this gold foil consists of number of atoms. As the alpha particles which falls onto this gold foil. So from this experiment, the size of the nucleus is of the order 10 to the power of minus 14 to 10 to the power of minus 50 meter. So from this experiment, the size of the nucleus, he found the size of this nucleus, that is accumulation of the positive charges into the small volume. So that size is of the order 10 to the power of minus 14 to 10 to the power of minus 15 meter. So as we studied in the kinetic theory of gases, the size of the atom, that is size of atom is about 10 to the power of minus 10 meter. So as we already studied in the class 11, that is from the kinetic theory of gases, the size of the atom is of the order 10 to the power of minus 10 meter. So here the size of the nucleus is 10 to the power of minus 14 to 10 to the power of minus 15. So from here, if we compare these two values, the size of the atom is greater than the size of the nucleus. So how much it is greater? That is of the order 10 to the power of 4 to 10 to the power of 5. That means the size of the nucleus is smaller than that of the size of the atom, right? So this one, the size of the atom is discussed in the class 11, that is kinetic theory of gases. From that, the size of the atom is of the order 10 to the power of minus 10 meter. So from this experiment, the size of the nucleus is of the order 10 to the power of minus 14 to 10 to the power of minus 15 meter. So the difference, that is size of the atom to size of this nucleus, right? So if we consider this whole as one atom means, so this size is of the, so this one is entire size of the atom is 10 to the power of minus 40 or minus 10 meter. Then only this positive charge, the size is from the experiment, this is about 10 to the power of minus 40 meter. Right? So this size is very small to that of the size of the atom. So this means that the space which the electron revolving around the nucleus, so this atom is almost have the empty space. From this he says that so the atom is of the empty space. Almost the atom is of the empty space. Hence the alpha particles which falls onto the atom will pass through this atom, because this atom is the empty space. For that reason only the alpha particles are not scattering, as it goes straight through this empty space. So if you observe here, so red color is the nucleus, then this black color represents the electron which is revolving around the nucleus. So this whole constitute called as the atom. So if we observe here, the size of the atom is greater than the size of the nucleus, that is of the order 10 to the power of 4, that is about 10,000 to 1 lakh. Hence the electron is at a distance of 10 to the power of 4, order of 10 to the power of 4 from this nucleus. That means the electron is about 1 lakh times that of the nucleus. So from this we can say that this atom is almost empty space, right? So for that reason only, as the alpha particles which falls onto this atom, it will penetrates and passes straight without any scattering. The particle which falls onto this nucleus, because alpha particle is also positive, the nucleus is also positive. So for that reason, here the repulsive force will happen out of 8,000 alpha particles. So all other alpha particles are penetrating straight like this, right? Only few will repulse. Out of 8,000, only one will repulse, because this entire is atom is of the empty space, right? For that reason only we are getting large number of the low angle scattering, right? So few percent, that is 0.14%, that is strong due to strong electric field. As it approaches near to this nucleus, then it will melt with a low angle, that is of the lesser angle, right? So for these observations he gives the satisfactory explain. So for this, why scattering is more means, because the size of the atom is greater than the size of nucleus, that is of the order 10 to the power of 4. That means the electron is revolving around the nucleus from this distance or about 10,000 meter or 10 to the power of 5 meter. That means almost 1 lakh order. It is at a larger distance. From this observation, he says that this atom is almost empty in space. Hence, as the alpha particle which falls onto the atom, easily it penetrates and it strikes without any scattering. Right? Next, only few. When it approaches due to strong electric field, then it will scatter only about 1 degree, that is of the percentage 0.14. Right? So next, out of 1 we are getting back scattering, means out of those number of alpha particles, as it approaches near to the nucleus, here the repulsive force takes place from the nucleus, hence we are getting the backward scattering, right? So these are the experimental observation and experimental explanations which are given by the Rutherford. So from this experiment, he says that the nucleus is positively charged and the entire mass of the nucleus is, entire mass of the atom is concentrated in the nucleus, and the electron is revolving around the nucleus at a larger distance from the nucleus, right? Next, the concept of the nucleus is also given from this theory. Hence, this experiment, that is Rutherford hypothesis, is called as nuclear atom model, right? So this is about the observation and explanation. So very simple experiment it is. So first we consider the source, that is radioactive source. So what are radioactive sources? Means the sources which emits the alpha particles, beta particles and gamma particles. So here from bismuth, the source which emits the particles are these alpha particles. So what are alpha particles? Means the alpha particles are the atom, that is nucleus of the helium atom. So alpha particles are the nucleus of the helium atom. The charge of the nucleus is, the charge of the alpha particle is plus 2e, that is plus 2e nothing but positive charge. So alpha particle is positive charge, right? So as the alpha particles are made to fall on this gold foil through parallel beams, hence after falling on this gold foil, the scattering will take place in all the directions. So that scattering will be observed by the help of the detector. So this detector consists of a zinc sulfate plate along with the microscope. When the scattering particles falls onto this zinc sulfate plate, the light flashes will observe through this microscope, right? So this one is about the circular table. So this detector can rotate along this circular table, right? So from this we can plot the graph, that is number of alpha particles, that is scattered alpha particles to the angle of scattering, that is angle theta. So here we are getting large number of scattered particles for lesser angle, that is almost 0 degree. So he gives the explanation that the size of the atom is very greater than the size of the nucleus, that is of the order 10 to the power of 4. From that he says that the electron is revolving around the nucleus at a distance of 10 to the power of 4, that is 10,000 order and or 1 lakh order. So from that this atom is almost empty in space, as the alpha particles which falls onto this atom, that is the atoms which are present in this gold foil, it penetrates through the atom without any scattering. Only the scattering will observe when the alpha particle which falls onto this nucleus, as alpha particle is also positive charge, nucleus is also positive charge, so the repulsive force exists. So due to this repulsion, the scattering will takes place. That is out of only 8,000, only one. If it is 16,000 means 2 alpha particles are scattering, right? So from that he says that the repulsive force is produced by this positive charge. If it is negative means there will be no repulsive, so it will be attractive. So the larger repulsive force for the backward scattering is produced by the nucleus which is present in the gold foil, that is atom. In that atom the nucleus is present, right? So from this he gives the explanation for the existence of this nucleus, right? So this is about the Rutherford alpha scattering, right? So in the next class we will continue the trajectory of the alpha particle, right? Thank you.